It is day 13 in geometry, and today is Monday, October 27th. Just gonna write that on here. Little note to self. Day 13. And we are gonna run through this practice quiz today. I'm gonna write answer guide where it says name. But you guys write your name. This is your exit ticket today. So make sure you've got it all filled out. So starting on our first page, first two problems, you are solving for the value of x. We're using the interior angle sum. So we're talking about angles inside of a triangle. What do we know about the sum of interior angles in a triangle? They equal 180. When you add them together, they equal 180. So we can write as a little side note, if this helps, angle A plus angle B plus angle C equals 180 degrees. We're going to be using that equation for both of these. So for number 1, I have 3 angles. We would label these as A, B, and C. It doesn't really matter what order we put them in. But what equation could I write to solve for x here? Yes, Jessica?
I did 35 plus 75 plus 74 plus x equals 180.
Okay, 35 plus 75 plus 74 plus x equals 180. We're just writing all the values, adding them together, equals 180. I'll draw a line on my equal sign. What do we do next?
Well, I combined all the numbers together.
Yeah, let's combine like terms. So what are you combining?
The 35, 75, and 74.
Yes, 35, 75, and 74.
That equals to 184.
Yes, that gives us 184 when we add them together. Bring down plus x, good,
Equals 180.
equals 180.
Then I subtracted 184 from each side.
Good. We just subtract 184 from each side.
Your x is equal to -4.
Perfect. X equals -4. And we circle our answer. And that's it for number 1. Yay! That's not so bad. Okay, somebody else. Number 2. 40 plus 80. Perfect. 40 plus 80 plus x plus 62 equals 180. Good. Okay. Draw a line through my equal sign. That really helps me. Where do I go from here? Add my like terms. What terms are like?
40, 80, and 62.
40, 80, and 62. So let's see, when we add those 3 together.
80.
Perfect. 182. So I'll bring down 182. What else comes down?
X
Plus x.
equals 1.
Good. Equals 180. Okay.
Subtract 182.
Yeah. Subtract 182 from both sides. And we get
X equals -2.
x equals -2. Very good. That is numbers 1 and 2. You're just adding the 3 angle values together, setting them equal to 180, and solving for x. And that's it. Do we have any questions about the interior angle sum? This one's a little more straightforward. So that's good. Okay. let's then scooch down to 3 and 4 before I move my paper. Does anyone need another second to write? Okay, yes. We'll wait for some of you here then. I'll pause and just tell me when you're ready. All right, so now we're going to go down to numbers 3 and 4. And now we're looking at the exterior angle theorem, which has a different sort of formula to it. All right, so with the exterior angle theorem, now instead of just A, B, and C, we're thinking of 4 different angles, but we're only using 3. So if I were to label my angles for number 3, as an example, maybe I would label them as A, B, C, D, like this. Where A is 3x plus 5, B is 7x, C is something, and D is 105.
I did mine totally different. I did A as 7x.
A is 7x and B is 3x plus 5. Yes, both ways will work. Both ways will work. But the main idea is that we're looking at the 2 angles that, and I'm not going to make those equal because I don't know if they're equal to each other. We're going to use the 2 angles that are not touching the exterior angle. And how are they related to my exterior angle? How are A, B, and D related to each other?
A and B together equal.
Yes. A and B together are equal to D. And we know that because A plus B plus C is 180 and D plus C is 180. So with this in mind, we can write a little formula over here. Angle A plus angle B equals angle D. So with that in mind, what equation could I write for number 3?
3x plus 5.
Mm-hmm. 3x plus 5 plus 7x
Equals 105.
equals 105.
102.
I'm going to draw a line through my equal sign.
You combine your like terms first.
Yeah, now we want to combine our like terms, and we want to be careful because now we have like terms that are x's. They have x's on them. So what do I do when I combine x terms on the same side of the equal sign? Add them together. Yes, do not subtract these.
It would be 10x.
3x plus 7x is 10x.
If you bring down the plus 5 equals 105.
Good. Bring down plus 5 equals 105.
You subtract 5.
Good. We subtract 5 from both sides.
Your 5's cancel when you bring down your 10x equals.
And
It'll be 100.
x equals, and 105 minus 5 is 100.
So you just divide by 10.
Good. Last step, divide by 10. Get that x by itself.
Equal to 10.
Good. Our x is equal to 10. Good. Good. Now that we know x is 10, if you were curious to plug your x in to find the angles, you don't have to do that because I didn't ask you. But if you did, you would notice that my picture is drawn horribly and accurately. That's okay. It's all part of it. All right. So x equals 10 for number 3. Start scooting this over and we'll take a peek at number 4. I'll leave number 3 where you can still kind of see it. So now if I were to look at number 4, What two angles would be my A and B?
The 7x plus 5 and 20x plus 5.
Yeah, that 7x plus 5, we could call that A. We could also call it B. It wouldn't matter, would it? This would be B. Now, angle C, we don't need, but it is right here. And that makes 118 our exterior angle D. Somebody else, I'd love to hear you give this one a shot. What equation did I write?
7x plus 5 plus 20x.
Good. 7x
Plus
plus
five.
5 plus 20x plus 5.
Equals 118.
Perfect. Equals 118. I'll draw a line with my equal sign.
Combine my terms.
Yes, we need to combine like terms. Do you want to do the x's first or the non-x's?
I put the x's.
Yeah, let's do the x's. So I have 7x and
20.
20x. That adds together to be
27.
good. 27x. And we could combine the
Plus
others. Yeah, plus 5 makes plus 10. So plus 5 and plus 5, they're on the same side, so we just add. Plus equals 118. Wait a second. Hello. We just started our practice quiz. There's some copies on that table there. Okay, so now we have 27x plus 10 equals 118. Subtract 10 on both sides. And I'll bring down 27x equals
108.
108.
You just divide by 27.
Yes, last step we divide by 27.
And your x is equal to positive 4.
Perfect. Equal 108 divided by 27 is positive 4. Okay, that is the rest of number 4. I'm going to go ahead and pause this and let everybody get this written down for page 1. And we'll move to page 2 in just a minute here. Okay, so let's go ahead to page 2. And now we have solving for x with the mid-segment theorem. So, using the mid-segment theorem, we know some things. Whenever I have a segment in the middle of a triangle, what do I know about how the length of that mid-segment is related to that opposite segment right here?
2 of those.
2 of the mid-segments, yes. One mid-segment can go into this side length here twice. So I can put 2 of these 2x minus 14s. So if doing this little visual helps, it's not a bad idea to do it. 2x minus 14 and 2x minus 14. So if I'm just trying to solve for x here, and I know that 2 of these are equal to 1 of the x minus 4 sides, what equation could I write? Jess?
I did 2 times 2x minus 14 equals x minus 4.
Good. We're always taking the shorter length, the mid-segment, times 2. So 2 times 2x minus 14 equals x minus 4. Now we distribute. Multiply both of these.
Yeah.
So 2 times 2x is 4x. 2 times minus 14,
-28.
negative 28.
You just bring the rest of your column down.
Yes, just bring it down. Equals x minus 4. Now, on this problem, once I brought everything down, I noticed a few things. I have x's on both sides of the equal sign, and I have non-x's on both sides of the equal sign. So when we combine like terms here, we don't just add the numbers. We need to do something different.
You gotta subtract the x from the side.
Yes. In order to combine our terms, we have to do the opposite so that we cancel things and bring them over. So, just like you said, Jess, we'll subtract x right here. You could have subtracted 4x, but then we would have a negative x on this side. It will still work. I just like to keep them positive whenever possible. So what happens over on the right side here? Yes, my x's cancel. No more x's on the right side.
It'll be 3x minus 28
Yes.
equals -4.
4x minus x is 3x. I'll bring everything down. Minus 28 equals negative 4.
You add 28 on each side.
Yes, now we're going to add 28 on each side. Bring down 3x equals
24.
the 24
You divide by 3.
divided by 3.
Your x is equal to 8.
Perfect. X equals 8 is number 5. So, to recap, we looked at our 2 lengths that were labeled. My shorter length, 2 of those is equal to 1 of my longer length. So, we took the shorter one times 2, set it equal to the longer one, distributed, solved. And we got x equals 8. So, looking ahead at number 6, somebody raise your hand and tell me what equation could I write for number 6? Milena.
2 times 29 plus 2x
Perfect.
equals x plus 25.
Beautiful. So we're taking 2 times the midsegment. 29 plus 2x equals x plus 25. Good. Okay, so what would I do next?
Multiply 2 times 29.
Yes, 2 times 29. Let's see. What does that give us? 58. 58. Okay.
2 times 2x.
Perfect.
4x.
2 times 2x is 4x. Beautiful. And bring everything down equals x plus 25.
You subtract x from each side.
Okay, yeah, now we're at a point where we have done our distribution, and now I want to get my x's together. We can't just add them, they're on different sides. So we'll subtract x. Both sides. Which means on the right side, our x minus x cancels.
4 minus x is 3x.
Yeah, 4x minus x is 3x.
You bring 58
Mm,
down and then the 25.
Good, we just bring everything down now. 58 plus 3x equals 25.
You just subtract 58 from it.
Yeah, now this part can be tricky because we're used to seeing the x first. Remember that we can't get rid of that 3x until it's by itself. Let's get rid of 58 first. Minus 58, that's positive, so we need to subtract. Which will cancel them on the left. I'll bring down 3x equals 25 minus 58.
Be negative 33.
Yes, negative 33. Perfect. Last step.
Divide 3.
Yes. Divide by 3. And we get
X equals negative 11.
perfect. X equals negative 11. Good job, guys. That is number 6. We'll leave that for just a minute here. And the next 2 problems, we're using the Pythagorean theorem if you're looking ahead. Does anyone still need to see number 6? I'm gonna go ahead and scooch my paper down then. All right, looking at number 7 and number 8, now I have 2 right triangles where we're solving for a missing side using the Pythagorean theorem. What is the Pythagorean theorem?
A squared plus B squared equals C squared.
Good. A squared plus B squared equals C squared. Now, what is kind of the rules? What are the rules for what A, B, and C have to be? Go ahead. Yes, Riley.
A and B have to be the shorter sides.
Yes. A and B have to be the shorter sides. These are also sometimes called the legs. The 2 sides that make the 90-degree angle. And then C, what does C have to be?
The hypotenuse.
Ah, the hypotenuse. The longest side, the slanted side. So, HYP, I'm going to abbreviate it. Hypotenuse, or the longest side. Okay. So, keeping that in mind, we're going to look at number 7. And before we set up an equation, let's decide what would be A, what would be B, and what would be C. What do we want to make A and B?
I'll put X there.
Yeah, let's make X our A.
And 9.8 would be.
Good. 9.8 can be B. And so C is 14.5. A, B, and C. Okay, so now that I know that, what equation will I write?
X squared
Mm-hmm.
plus 9.8 squared equals 14.5 squared.
Good. X squared plus 9.8 squared equals C squared, 14.5. Squared. Don't forget squareds. So now we have an equation written. Once I've plugged in those numbers like we have, what should I do next? Yeah, let's square 9.8. So in my calculator, I'm going to type 9.8, and then I'm going to use the x squared button.
96.04.
Yes, and I'm getting 96.04. So I'll bring that down. 96.04. Equals What am I doing now?
The 14.5 squared.
Yeah, 14.5
That
squared.
gives you 210.25.
Good. 210.25. 10125. And what else?
The x squared.
Yes, I need to bring down my x squared. There we go. So now my equation reads x squared plus 96.04 equals 210.25.
Yeah, subtract the 96.
Yeah. Let's subtract 96.04 both sides.
Bring down the x squared, and then it equals 104.21.
Good. Bring down x squared.
114.
Bring down equals. And then,
114.
yes, 114.21. Are we done?
No.
No. What now?
Okay, square both sides.
Yes, we need to square root both sides. So that's the last step. That will give us x by itself. And I'm gonna use my square root button. Second, x squared, there's my square root. And I am just gonna arrow up to the answer. I got 114.21.
It'll be
Enter.
10.686908.
There we go. 10.68690788. If it were me writing my answer, I would probably put 10.69, round that 8 up. But you could put 10.6, you could put 10.7, you could put 10.68, 10.69. I won't be picky about your decimals. As long as you don't just put 10, put at least one decimal place. I'm going to write 2, 10.69. So x equals 10.69. What are my units? My units of measurement. Inches. I know we haven't used units much lately, but this is a length, so we do want to write inches. And that is our answer for number 7. Okay, so now let's look at number 8. I'll leave number 7 where you can still see it. And what could I use for my A, B, and C here?
You can use 4.8 as your A,
A, 4.8,
5.2 as B,
B, 5.2,
X is C.
X will be my C. So I'll just plug that in to Pythagorean theorem. 4.8 squared plus B squared 5.2 squared equals C squared or X squared. What do I do now?
You square the 4.8
Yeah, let's square 4.8.
be 23.04.
Good. 23.04 plus.
You square the 5.2.
Mm-hmm.
It'll be 27.04.
7.04
And you just bring it down to X squared.
equals x squared.
Then you just add it together.
Yeah, now we just add these together. They're like terms. No x's on this side. So I add those two together.
You get 50.08.
Good. 50.08 equals x squared. And last step.
You square this Square root.
Square root, good, square root of both sides. That gives me x by itself and 50.08, square root of that.
7.07.
Yeah, 7.0767224005. I am gonna use 2 decimal places. So 0.08, we'll round up one. Good, 7.08. If you put 7.07, I will not count it wrong. Not grading you on your rounding skills. So 7.08 inches, thank you. That was our second page. I'm gonna leave that up for a minute in case anyone is still writing. And feel free as you're looking over things and writing things, if there's any questions that come up, this is a great time to ask. Okay. So let's go ahead to page 3. Oops, didn't mean to make that small. Okay, so now we are looking at special right triangles. Now, these are the 2 types where you have either a 30, 60, 90 triangle or a 45, 45, 90 triangle. So, looking at number 9, what kind of special triangle is this?
30, 60, 90.
Yeah, it's a 30, 60, 90. So, if we remember back to, look, I'm going to get my notebook out and I'm so glad I made a handy little tab. Special right triangles. Ah, and look, all my steps are right here. Okay. So, step 1. Label side lengths with X values. So let's do that. I'm going to just put it literally right beside my quiz. And this is what it'll probably look like when you guys are taking your quiz, looking through your notes and stuff. So I'm going to label my picture and I'm going to label my little given and find values. So starting from, let's see, our given is that AC, which I labeled the picture already, is 9.53. What X value does AC have?
Equals X.
It's X. Okay, so I could just write X equals next to AC. And that's really nice. We already know our X value. I could also over here write equals X. Okay. Now what would I label BA with?
Vertical 3. X vertical 3.
X radical 3 is my BA. So X radical 3. I'll write it over here too. X radical 3. Okay, and then BC, what is that one?
2x.
2x. 2x. Okay, so that was step 1. We labeled everything. Step 2, solve for x if it's not already given. How do I solve for x for this problem?
This is already given.
X is already given. Look at that. X equals 9.53. We could also see it on the picture. X equals 9.53. Step 2 is done.
You just have to plug in that.
Yeah, we're just plugging it in. Now that we know x, plug in x to solve for missing sides. So I'm trying to find BA and BC. I know that BA is x radical 3. I know x is 9.53.
So you plug in the A.
Yeah, plug in 9.53 for x. 9.53. And remember, this is times radical 3. Or you don't even have to push the times button. You can just type 9.53 radical 3. So, same thing as a square root. I need to get that to focus a little bit. I'm just going to type 9.53 second square root 3. And I got 16.5. I'll round up to 1. 16.51. Yep. You guys getting that? Good? Good. Okay, so that is 16.51 for BA. So I can write over here 16.51. I didn't give you units, so you don't have to do units. Now, how do I find BC?
2 times 9.53.
Yep, we're just gonna plug 9.53 in for x again. BC is 2x, so we're taking it times 2.
It'd be 19.06.
Sure you're correct. See? 9.5 times 2. Yep, 19.06. And that's for B and C. So 19.06. Go. And that is number 9. So make sure that you have these labeled. If not on your practice quiz, somewhere in your notes on a sticky note, you will need those X values. I won't give them to you on the quiz. You'll have to have them written somewhere. So don't forget to write them. Let's speed that up a little bit and zoom it out. And let's look at number 10. What kind of special right triangle do we have for number 10?
45, 45, 90.
Yes, 45, 45, 90. So we want to label our X values. Show it. There's my picture. So I'll start with my given side. EF is 12.15. What is EF's X value?
X to the 3.
X radical 2. Put that over here as well equals X radical 2. And let's go ahead and label, bless you, my other sides. How about DF? X. And the other one's X. Yes, both of these are X. So I know these are both X. So once I solve for X, that's it. I've got my answers. So I know that EF is 12.15, and I know that EF is X radical 2. What equation will I use for the next step to solve for X?
45, 45, 90.
We're using a 45, 45, 90. But what equation will I write? Already written for you.
12.15 equals X radical 10.
Yes, we're just going to use this that we just wrote. 12.15 equals X times radical 2. And we're going to solve for X. So what am I going to do here to solve for X? Divide. This is X times radical 2. To get X by itself, we divide by radical 2. If you're worried you'll forget, write that. Divide. 2. Okay, those will cancel. I'll have X by itself. And on your calculator, when you're typing this, 12 0.15 divided by second radical 2. Make sure you don't type radical 3. Double check that.
It'd be 8.59.
Good. I got 8.59. Did everybody, I want to make sure everybody's able to get that same number. Make sure your calculators are working. You should get 8.59 for x. Now, if you get to this part of the problem and you just circle this and say you're done, you're not technically done. We need to label both of the sides.
8.59.
They're both 8.59. They're both x. 8.59, 8.59. Those are answers. 9 and 10. Show them both again here. Now, I know these are probably some of the trickiest problems to some of you on this quiz, depending on how comfortable you are with it. I do have a practice worksheet that Kelsey had me make last Thursday. Yes, and I think it is very helpful sometimes if you're struggling with a skill to just drill it and do it a bunch of times. After we finish this practice quiz, if any of you feel like you want practice with this specifically, I have a worksheet for you. So just let me know at the end. I'll have them out so you can grab them if you want one. Okay. Does anybody need more time to write number 10? Yes, I will wait. Just let me know when you're ready. I'm going to go ahead and shift our paper up, but I will leave number 10 where you can see it. For numbers 11 and 12, we are now classifying triangles by sides and angles. So, my first 3 options, scalene, isosceles, equilateral, we are referring to side lengths. My other 3 options, acute, right, obtuse, that is referring to angles. So, I am going to look into my notebook and notice I have another little tab that says triangle type. When I go to that tab, all the answers are right here. We have acute, right, and obtuse. So if I were classifying by angles, acute has all 3 angles less than 90. Right is 1 angle that's 90. Obtuse is 1 angle that's greater than 90. So let's look at the angles. For number 11, let's see, 40 degrees, 77 degrees, 63 degrees. $40. Is this an acute, a right, or an obtuse angle?
Acute.
That's acute. 63, is that acute, right, or obtuse?
Acute.
Acute. 77 degrees?
Acute.
Acute. What kind of triangle is this?
Acute.
This is an acute triangle. Acute. Now let's look at the sides. 10.8, 7.8, 11.8.
The scaling.
This is a scalene triangle. None of the sides are the same length. I'll start with the smallest side. There's only, none of them match. Next smallest, I'll get it 2. Okay. And then 1, 2, 3. None of them are the same. This would be scalene, acute scalene. It would still be correct if you wrote scalene acute. I don't care what order you put that in. So now for number 12, look at our angles again. 35, 55, and 90. What kind of triangle is this?
Right.
It's a right triangle. As soon as you see that 90-degree angle, it's a right triangle. Now, look at the sides. One is 2.1. It's scaling. Good. The next one is 3. The third one is 3.7. They're all different. 3 different sides. So, right scaling. Good. Okay, so that is the 3rd page done. We're going to go to the 4th page here in just a second. I will leave this up for a minute. If anyone is still writing, see if you're still writing, so I will wait this a minute here. Let's go ahead then and flip to page 4. Last 2 questions. Now we are stating whether or not each set of side lengths could form a triangle using the triangle inequality theorem. This is the last thing we talked about on Thursday, I believe.
Yep.
So if you were not here Thursday, you might want to watch that video or just pay real close attention right now. Because this isn't too hard, I promise. So the triangle inequality theorem works like this. Here's the notes we took on page 12. A plus B must be greater than C. A and B are the shorter sides. C is the longest side. So, for example, we had 12 inches, 5 inches, and 30 inches. We add the 2 shorter sides together, A and B, and see if they are greater than C. When I add those together, I get 17. 17 is greater than 30. We said that's not true because it's not. And because it's not true, the answer is no, not a triangle. So we're doing the same thing here. And looking at number 13, let's first circle our biggest side length. What would that be?
25.
25. What am I going to do with the other 2?
Adam.
Add them together. So, 12 plus 13, what is that?
25.
25. So 25 is greater than 25. Is that true?
No.
No.
Not true. Not true. No. Now, on this quiz, you do need to show your work, you guys. If you just circle yes or no, I will not know if you're guessing or if you actually did the work. So please write your work just so I know what you did, and I can give you all your points. Okay.
Taylor, that's
Yes.
43 or a 48?
Where?
On 14.
Oh, I'm sorry. It's a 43. Yes, if there's ever any of my numbers that you can't read, definitely ask. That happens. So out of these 3, 37, 43, and 27, what's my largest side?
43.
43. And so the other 2 I add. 37 plus 27 is 50. 64. 64. So 64 is greater than 43.
Yes.
True. So yes, it is a triangle. There we go. That's it. That's your quiz. Now we are going to go over the bonus question.
Do we have?
You don't have to. If you want to be done, you can be done. However, we are going to go over the bonus. So at this point, if any of you are not interested in the bonus and you're trying to get out of here, you are free to go. I've counted that you're here. In about a minute here, though, we are going to finish the bonus question. So I'll just pause for a moment while everybody is settled and deciding whether to stay or not. All right, so the bonus, it is optional, as always. But for our bonus, we are thinking back to last unit and our angle relationships. So there's a few.
This is where you use the circles.
Yeah,
Okay,
you can
okay.
use the circles for this, absolutely. Now the only issue is we don't have any parallel lines here. So let's talk about what else we can use to help us find things when it comes to angles. So I'm gonna make a little sticky note. What do I know about, let's say I have A and B. How are these angles related?
Across each other.
They're across from each other. So what does that mean? They're equal. So when angles are vertical like this, they are equal. So this is something good to remember. Another good thing to know is that in a triangle, if I have X, Y, Z, we know that adds up to 180, right? Have one more relationship that will be useful. That is that when I have angles that make a straight line, let's call this C, D. What do I know about C and D? They're not equal. So I don't know that they're equal to each other, but I do know something about them.
They
Yes, they add up to 180. C plus D equals 180. So we're going to be using vertical angles, triangles, and straight lines. 3 things to be looking for. So the goal of this bonus question is to find the measure of angle Z, which is right here. And we do not have enough information yet to find angle Z. So when you are coming across a problem like this where right away I don't have an equation to solve for Z, let's see what we can solve for. So let's see. Out of everything in this picture, is there any other angles that we could label right away?
The opposite side of 37.
Yeah, 37 has a vertical angle right here. These are equal, so this is 37 degrees. Two, because I don't know that the Z is the same. What else do I know?
what 40?
40.
On the other side of the triangle.
Right here is a triangle, yes. Give you a hint. There's your hint.
Is that also important?
I don't know what this is yet. Actually, you're right. Yeah, it will. It will be 40.
I guess it.
You did. You guessed it right.
The triangle literally looks like.
Now, there's a reason that this is 40 degrees. They're not vertical angles. These 2 angles are not a triangle. What do I know?
They add up to 180.
They add up to 180. So 40 plus, we'll call that X, equals 180. So let's solve for this one first. So I'm going to pull this out and I'm going to write x plus 140 equals 180. Good, subtract 40. And we get x equals 180 minus 140 is 40. So I know that this angle is 40 degrees.
I was checking.
Yes.
It really was.
That's funny. Yes, so that angle is 40 degrees.
It's just because it looks like the exact.
Right. It really does.
I don't know, it does the same thing.
So I know this angle's 40. I know this angle's 40. Now that I have found another angle, can I find anything else?
Can you use it for the whole, like, line?
The line. What do you mean?
Like 140 and 40.
Is that
Would
why?
you use that for the line underneath Z?
The
Yeah.
line underneath Z right here?
Yeah, like that.
You could, but I don't know this angle yet. So it's not helpful for me yet. Let's start from here. If we just found that this is 40, and I know that this is 40,
90.
I don't know that it's 90. But can I solve for this angle?
Each triangle equals 180.
It's a triangle. This is a triangle. So this x plus 40 plus whatever that is 180, right? Yeah. So here's,
D and D.
let's see. I don't know what this is. Call that y. But I know that 40 plus y is 180. Yes, combine like terms.
Just 80.
Good. 80 plus y. 180. Minus 80 on both sides. Y equals 100.
So that's 100.
Yes, so that is 100.
Just looking at it, you could guess that as well.
You could.
Because 40 plus 40 is 80.
Right. You can start to do some little things in your head. Now, if this is 100 degrees, what else do I know?
On the other side, so where 37 is.
Right here?
Yep.
What is this?
100.
100 vertical angle. They're equal. So this is 100. Now what?
37 plus 100 plus, let's say that corner's Z.
Yeah.
Not Z, but I mean, I guess we could.
We could use Z, couldn't we? Because how is Z and that angle related? They're the same. So this is also Z. I can solve for Z finally.
Basically, your terms. All the steps you learn.
Yes.
Figure
Yes.
out where they are.
Exactly. So to find angle Z, we will do the same thing we just did. 37 plus 100 plus Z equals what? 180.
37 plus 100 is 137.
137 plus Z is 180.
-137.
Minus 137.
So Z equals 43.
Z equals 43 degrees. That is your answer.
So
As long as it's just confusing. I mean, it is confusing, but it's not as confusing as I thought it would be.
Right. It makes sense, but we just haven't done something as involved as this one. But you can do it. You totally can. Just takes a little bit more thinking. Thinking about all the things you learned. Okay, so that has been our bonus question. And it is 2:00. That's exactly what I said. Okay, so guys, that's our practice quiz. I will have this video uploaded in a few minutes here. For the rest of the week, all that you need to finish is this practice quiz, and you need to just take the quiz before Friday. I do have copies of it ready. If any of you are wanting to start on it today, you can. But we're gonna take it as a class tomorrow. So really that is entirely up to you all. So I'm gonna end our recording and that's it.